5 years ago, if you wanted to build a custom software tool to automate your business, you were staring down the barrel of a $150,000 invoice.
Oh, at least. Easily.
Right, at least. You were going to hand that money over to some specialized development agency, and then you were just going to sit on your hands for like 6 to 8 months waiting for them to deliver a minimum viable product.
Yeah, and hoping it actually worked.
Exactly. But today, in 2026, the barrier to creating a globally scalable software empire has just completely collapsed.
Right.
It has dropped to a laptop, 16 hours of your time, and a $40 a month AI subscription.
It's wild. The ultimate gatekeeper of the modern economy, which is syntax, is just dead.
Yeah, English is now the final programming language.
We are looking at a total structural paradigm shift in wealth creation right now. I mean, the traditional software development agency model is being entirely hollowed out.
Completely gutted.
Yeah. And in its place, we're seeing the birth of the 48-hour SaaS. We have these solo operators, people with zero traditional coding background, spinning up micro software companies that generate $50,000, sometimes $80,000 in monthly recurring revenue.
And they're doing it entirely through natural language.
Entirely, just talking to a machine.
Welcome to this deep dive on MediaGenX. We are stepping in as your independent analyst today to really explore this massive intersection of technology, finance, and leverage. We're unpacking the vibe coding gold rush.
Right, and over the course of this briefing, we are going to dissect the exact mechanics of how non-technical founders are architecting these extremely lucrative micro empires.
We're going to give you the specific, actionable playbook for this new economy. But, and I really cannot stress this enough, you have to stick around for the second half of this discussion.
You really do.
Because while we're going to outline all this incredible leverage, we are also going to tear into the terrifying dark side of this movement.
The technical debt singularity. Yeah. I mean, the catastrophic security liabilities and the sheer legal danger of owning $1 million live code base that you literally do not know how to read.
It's a massive blind spot. The leverage here is unprecedented, sure, but the structural risks are equally astronomical.
Exactly. If you're going to deploy capital or time into this space, you have to understand the blast radius when these AI-generated systems inevitably fracture.
So to really grasp the magnitude of what's happening right now, we need to strip away all the hype and just look at the underlying mechanics. I mean, why does a $40 monthly subscription suddenly replace an entire floor of highly paid senior engineers?
Right, we have to look at the 50-year technological arc that basically engineered this exact moment.
Let's get into that arc.
Well, the lens you need to look through here is the concept of abstraction.
Abstraction?
Yeah, the entire history of human-computer interaction is really just one long, relentless campaign to hide the physical complexity of the machine behind a more, human-friendly interface.
Right, hiding the messy stuff.
Exactly. Every time we successfully abstract a layer of complexity, we trigger a massive economic boom because we lower the barrier to entry.
Let's track that arc, because it really puts the sheer violence of this current shift into perspective. I mean, the friction in the early days wasn't just mental, right? It was literally physical.
Oh, highly physical. Yeah. In the 1940s and 50s, the earliest programmers, people working on systems like the ENIC, they were engaged in agonizing manual labor.
Like actually plugging things in.
Yeah, they weren't typing on keyboards. Programming meant physically plugging and unplugging these thick patch cables across massive wall-sized switchboards.
Wow.
You were manually flipping heavy binary switches to represent ones and zeros. You were physically routing electrical currents to execute logic. That is the rawest, most unabstracted form of human-machine interaction. The friction was just absolute.
Which means the pool of people capable of programming was severely restricted. Like, you had to be an elite mathematician or an electrical engineer who actually had physical access to these room-sized mainframes.
Right, you had to be in the room.
So the first real escape from that physical labor was assembly language, right?
Yeah, assembly was the first major leap in abstraction. Instead of dealing with raw electrical binary, humans could suddenly type short mnemonic codes.
Like what?
Like ADD or MOV, to represent hardware instructions. It was still incredibly dense, obviously. You still had to understand the exact architecture of the CPU you were working on.
But you weren't carrying cables around.
Exactly. You were finally a step removed from the physical hardware.
But the real economic shift started when we abstracted the hardware away entirely. With languages like C and C++ Bray,
Right.
you stopped thinking about individual logic gates and registers.
Right.
You started writing logical functions like loops, conditionals, and a compiler did all the heavy lifting of translating your human-readable logic into the machine code.
Which is a huge leap.
But, and I've looked at legacy C++ code bases, that era was still famously brutal. I mean, the hardware was abstracted, but the memory was not.
Oh, the memory management. That is the critical bottleneck of the C and C++ era. You basically had to act as the computer's memory manager.
Which sounds exhausting.
It was. You had to explicitly command the system to allocate a specific chunk of RAM for a variable. And then, this is the worst part, you had to explicitly command it to free that memory when you were done.
And if you forgot?
If you forgot to free it, you created a memory leak.
Right.
The program would just slowly consume all the available RAM until the entire server crashed. And if you accidentally tried to access memory you had already freed, you got a segmentation fault and the program just died instantly. The cognitive load was immense.
And that cognitive load served as a massive economic moat. The developers who could actually navigate that complexity, they were this highly lucrative, deeply entrenched guild.
Definitely a guild.
But then we hit the next wave of abstraction, right? Python and JavaScript. And the underlying mechanism that changed the game there was garbage collection.
Garbage collection fundamentally altered the demographics of software development. Languages like Python abstracted away the memory management entirely.
So you don't have to manually free the RAM anymore?
Nope. You just declared a variable, and the language runtime handled the allocation and the cleanup behind the scenes. You didn't have to worry about pointers or memory leaks at all.
And the economic ripple effect of that one abstraction was just staggering. By removing the need to manage memory, Python brought millions of people into development who were not low-level systems engineers.
Right, suddenly data analysts, biologists, quants on Wall Street, hobbyists, they could all build functional software.
It exponentialized the output of the tech sector.
It really did. Every single leap, from cables to assembly, from assembly to C, from C to Python, it does the exact same thing. It hides the machine, it lowers the barrier, and it multiplies the number of humans capable of creating software.
But even with Python and JavaScript, we still hit a wall. I mean, think about the old software industry, even just 5 years ago. It was essentially a heavily guarded toll bridge.
I love that analogy.
Right. The developers were the toll collectors. You, as a founder with a business problem, had to pay them hundreds of thousands of dollars just to translate your human intent into executable syntax.
Because you couldn't do it yourself.
Exactly. Because even in an easy language like Python, if you missed a single colon or, misaligned an indent, the compiler rejected you entirely. You were locked out.
Locked out completely, because all of those previous languages still forced the human operator to think like a machine.
You had to speak their language.
Right. You still had to take a grand, fluid human vision and manually shatter it into thousands of tiny, sequential, rigid logical loops, arrays, and variables. You had to conform to the machine's architecture.
Which brings us to the final leap, the abstraction that shatters the toll bridge entirely.
Vibe coding.
Vibe coding.
We have reached the terminal point of this 50-year arc. Vibe coding is the complete and total abstraction of syntax itself. AI has evolved way past the point of being a helpful autocomplete tool.
It's not just suggesting the next word anymore.
No, we are no longer talking about a passive Copilot that just suggests a line of code while you type in a traditional text editor. We have crossed into the era of the autonomous, stateful Agentic IDE.
Let's define that for the listener, because the distinction between a Copilot and an Agentic IDE is where the wealth is actually generated.
It's a crucial distinction.
Tools like Cursor or Windsurf or the Replit agent, these aren't just advanced spell checkers for code. They are integrated development environments that have actual terminal access, file system access, and iterative reasoning capabilities.
Exactly. When you are operating one of these agents, you are no longer writing logic. You are no longer thinking about loops or arrays or database routing.
I have to stop you there, though, because that fundamentally redefines the entire job. Like, if I am sitting at my laptop and I'm not writing logic, what am I actually doing? What is the output of the human in this equation?
You are writing intent. Yes. In this paradigm, the human operator has been elevated way up the abstraction chain. You are the product manager, the system architect, and the quality assurance tester all rolled into one.
And the AI.
The AI is your infinite, tireless, senior engineering team. Your job is to define the boundaries of the system, the business logic, and the user experience. The AI agent translates that human intent into the necessary logic, writes the syntax across multiple files simultaneously, and handles the whole deployment architecture.
The economic implications here are just violent. We are witnessing the real-time destruction of the traditional development agency.
Overnight.
The classic model of spending 50 grand just to see if an idea works, the capital-intensive minimum viable product phase, that's just dead. Software used to be a massive capital bottleneck. The primary question a business had to ask was, can we afford to build this?
And that bottleneck has just evaporated. Software creation is no longer a capital endeavor. It is now purely a taste and distribution endeavor.
The friction has moved.
Exactly. The question is no longer, can we build it? The question is strictly, should we build it? And do we have the distribution channels to sell once it's live?
I want to take this out of the theoretical and show you exactly what this looks like in practice, because the speed of execution is honestly hard to believe until you see the workflow.
It feels like magic the first time you do it.
Let's dig into a real case study from our sources, the Landscaper app.
Walk through the exact interface experience for them. Like, what does the founder actually do to spin this up?
Okay, so you open your Agentic IDE. Let's say you're using Windsurf. You don't open a blank Python file. You open the chat interface and you just write a plain English command.
Just normal text.
Yeah, you type, build a web application using Next.js and Supabase. It needs to allow commercial landscapers to upload their PDF contracts. The AI should extract the total square footage, the material requirements, and the project deadline, and then populate that data into a central dashboard.
Okay, that's already a lot.
It gets better, you add. Include a Stripe integration for a $49 a month subscription. Make the UI dark mode, clean, and highly responsive for mobile.
The density of that prompt is key. You're specifying the front-end framework, the back-end architecture, the core business logic, the monetization layer, and the design aesthetic in literally a single paragraph.
You hit enter, and then you just take your hands off the keyboard. You watch the agent go to work. It scaffolds the Next.js project. It writes the React components for the front end.
It's writing multiple files at once.
Right, and it automatically configures the Supabase backend, setting up the Postgres database tables to handle the uploaded PDFs and the extracted data. It writes the API routes to connect the front end to the database. It integrates the Stripe billing portal, and then it deploys the entire application to a live URL.
And according to the source data, the time from hitting enter to clicking a live functioning URL is roughly 4 minutes.
Wait, 4 minutes? Like total?
4 minutes. To go from a conceptual paragraph to a deployed full-stack application with a live payment gateway?
That is just absurd.
It is. But the real leverage isn't just in that initial generation. The true power of the Agentic IDE is how it handles failure in iteration. Because, what happens when the first pass isn't perfect?
Right, this is where it gets wild. Let's say you click the live link, you test the app, and you discover a flaw. You realize the PDF parser is failing when a landscaper uploads a scanned handwritten document instead of a clean digitally generated PDF.
Which is super common in that industry.
Very common. Now, in 2021, discovering that flaw means you are opening a Jira ticket, scheduling a sprint planning meeting with your dev team, researching third-party libraries, and basically burning a week of expensive developer time to fix it.
Oh, easily a week.
Yeah.
But in the vibe coding era, you don't even look at the underlying code to fix it.
You don't.
Nope. You simply go back to the chat interface in your IDE and you type, the PDF parser is failing on scanned documents. The system needs to integrate an OCR layer to read image-based text and then route that data back through the extraction logic. Fix this.
Optical character recognition.
Exactly. And this is where the agent behaves differently than a simple chatbot. It actually reads your intent, it searches its knowledge base for the optimal OCR library, it installs that library into your project via the terminal, it rewrites the backend logic to route the file through the OCR process before hitting the database, it commits the changes, and it pushes the update live.
You are literally just having a conversation with the machine to execute complex system engineering. You are vibing your way through software development.
The compression of the idea to execution pipeline is total. Let's look at the hard numbers on another case study from the sources to really cement the unit economics here. The dental lab 48-hour sauce.
This one is a masterclass in the new economy. So the founder identifies a hyper-specific friction point, inventory management and compliance tracking for independent dental laboratories.
Very specific.
It is a niche, boring, high-value problem. On a Friday evening, the founder sits down and drafts a highly detailed product requirements document, a PRD, mapping out exactly how the software needs to function. They feed that PRD into their Agentic IDE.
And the agent just works through the night.
Exactly. By Saturday morning, a fully functional MVP is live on the internet.
The capital allocation shifts entirely here. The product is built instantly, so the founder's energy goes 100% into distribution.
Right. Saturday daytime isn't spent debugging code. It is spent running hyper-targeted LinkedIn ads and executing cold email outreach directly to dental lab owners. By Sunday night, literally 48 hours after writing the PRD, the founder has successfully onboarded 5 paying beta customers.
Let's break down the margins on that weekend, because this is the math that changes industries.
Those 5 customers are paying $99 a month. What was the founder's total capital expenditure to launch this globally scalable SaaS company?
Basically nothing.
They spent roughly $40 in AI API credits for the underlying model, and they spent $20 to register a domain name. $60 total.
Unbelievable.
And the time investment was 16 hours over a weekend.
When your cost basis to launch drops from $150,000 to $60, you can certainly pursue micro markets that venture capital previously considered entirely unviable.
Because they weren't big enough.
Right. You don't need a total addressable market of $1 billion anymore. You can build a highly lucrative business in a market that only has 1,000 potential customers.
But wait, I have to push back hard on this. I'm looking at these numbers and I'm listening to this workflow. If it only takes 16 hours and $60 to build a software company that generates real recurring revenue, why isn't every single person listening to this briefing a millionaire right now?
That's the $1 million question.
Literally. You're telling me I can build a globally scalable app for the cost of a nice lunch. But what about server costs? What about database scaling? An AI can write the code, but it doesn't pay my AWS bill when the app actually gets traction.
It is the single most important question, and the pushback is entirely justified. The infrastructure costs don't just vanish.
Okay, so how does it work?
But the modern architecture that these agents use, like serverless functions on Vercel or managed databases on Supabase, it means your computing costs scale linearly with your usage. You only pay for the exact compute you use.
So it's pay as you go?
Exactly. By the time your AWS or Vercel bill hits $1,000 a month, you have enough paying users that your MRR is 10 times that amount. The unit economics remain highly profitable.
Okay, assuming the infrastructure costs scale with revenue, there's still a massive gap between anyone can do this and everyone is doing this.
A huge gap.
And this brings us to the contrarian reality of the vibe coding economy. We have to violently challenge the popular narrative that is being pushed by the mainstream tech press right now.
The mainstream narrative is aggressively misleading on 2 fronts. First, they are pushing the idea that prompt engineering is the most lucrative job of the future.
Right.
And second, they are telling ambitious founders to use AI to build the next massive, world-changing consumer application.
Yeah.
You know, the next Tinder, the next Facebook, or the next global AI wrapper.
And the sources make it crystal clear. Both of those narratives are dead ends. They are graveyards for capital and time. Let's tear down the prompt engineering myth first.
The concept of prompt engineering, the idea that you just need to find the perfect magical incantation of words to trick a language model into giving you flawless code, was a temporary hallucination.
A total myth.
It was a band-aid for weak, early generation models that basically lacked reasoning capabilities.
Amateurs approach an Agentic IDE like it's a magic wand. They type in one vague sentence like, "Build me an app that connects dog walkers with pet owners," and they expect a billion-dollar platform to spontaneously generate. And when it spits out a buggy, hallucinated mess, they blame the tool.
But professionals do not treat AI like a magic wand. They treat the AI agent like a highly literal, infinitely fast, but easily confused savant.
That's a great way to put it.
And that fundamental shift in mindset is the exact difference between the dead concept of prompt engineering and the new, highly elite skill of context engineering.
This distinction is everything. Prompt engineering is like pulling your car up to a fast food drive-thru, yelling an order into a blurry, static-filled microphone, and just hoping you get the right meal.
Good luck with that.
Right. But context engineering is like acting as the lead architect and handing a hyper-detailed, mathematically flawless blueprint to a foreman. You aren't just giving the foreman a command to build a house. You are defining the exact structural load of every beam, the routing of every electrical wire, and the exact sequence of construction. You are engineering the environment.
That is exactly the underlying mechanism. Context engineering is the rigorous discipline of architecting the exact informational environment that an autonomous agent requires to execute complex, multi-step system tasks without hallucinating or breaking the architecture.
And to do this, you have to master the concept of the context window.
Right.
For those navigating this space, let's unpack the context window. You can think of the context window as the AI's working memory, or its
Short-term memory.
Exactly. It is the finite amount of text, code, and documentation that the model can hold in its head and actively consider at any given millisecond while it generates an output.
And if you dump messy, contradictory, or incomplete information into that working memory, the AI is mathematically guaranteed to output a messy, contradictory, and broken application.
Garbage in, garbage out.
The model is simply a reflection of its context. Elite context engineers understand that they need to curate that context window with absolute precision.
So what does that actually look like on a Tuesday? What is a master context engineer actually doing for the days before they ever ask the AI to write a single line of syntax?
They are meticulously drafting master system prompts. They are writing exhaustive product requirement documents that leave absolutely zero room for interpretation.
No vague instructions.
None. They are explicitly defining the database schema. They tell the AI exactly what tables need to exist, exactly what data types go in each column, and exactly how those tables relate to one another via foreign keys. They leave nothing to the AI's imagination.
The edge case definitions are where the real pros separate themselves, I think. You don't just tell the agent to integrate a straight payment system. An amateur does that, and the moment a credit card declines, the app crashes.
Instantly.
You have to map the plumbing. You have to define exactly what happens when a Stripe webhook fails.
And a webhook, in this context, is just an automated digital ping from Stripe to your server, saying, hey, this monthly subscription payment just failed due to insufficient funds.
Right.
If you haven't engineered the context for that specific event, the AI will likely just ignore it, or worse, it'll guess how to handle it. And when an AI guesses how to route a failed payment, it usually routes it right into a digital brick wall, causing the user state to desync.
An elite context engineer provides the agent with the exact JSON payload structures that the Stripe API is going to return. They map out the exact user flow for every conceivable failure state. Like, if the webhook returns a 402 error, instantly revoke the user's pro-tier database access, trigger an automated email via SendGrid, and render a persistent banner on our dashboard requesting a new payment method.
You are mapping the logic so tightly that the AI is literally just executing the translation.
And beyond just structuring the instructions, context engineers are utilizing advanced architectural tactics like RAG retrieval augmented generation to feed the AI entirely new information that it wasn't even trained on.
Array is the secret weapon here.
I'll break down the mechanics because it sounds incredibly complex, but it's conceptually brilliant. Language models have a knowledge cutoff date. If a new version of the Next.js framework comes out today, the AI doesn't know about it.
It's blind to it.
If you ask it to code using the new framework, it will hallucinate and write deprecated broken code. RG solves this. Instead of relying on the AI's frozen training data, you use a vector database to store the actual up-to-the-minute documentation of whatever API or framework you want to use.
And then when the AI agent needs to write a function for that specific API, it first queries your vector database, retrieves the exact relevant paragraphs of the official documentation, pulls that text directly into its context window, and then writes the code based on the fresh data.
You are mathematically injecting the facts into the model's brain right before it speaks. You pair that RJ architecture with a comprehensive codebase map, which is basically a living document that forces the AI to understand exactly how your front-end UI components are supposed to talk to your back-end API routes, and you effectively eliminate hallucinations.
You are managing the flow of information into the mind of the machine. It's a highly technical, rigorous discipline.
Armed with this elite discipline of context engineering, the question becomes, where is the highest ROI to apply this massive new leverage? And this brings us back to the second mainstream myth, the consumer trap.
Right. If context engineering takes days of intense preparation, and you have this godlike power to deploy software instantly, it makes absolutely zero sense to build a consumer app.
Please do not build a to-do list app.
Don't do it. Do not build an AI dating coach. The consumer market is a bloodbath. You are fighting astronomical customer acquisition costs, brutal churn rates, and you are competing directly against multi-trillion-dollar tech monopolies that can clone your feature in a weekend.
The ROI simply isn't there.
The wealth of the vibe coding era flows to the people who target tiny, unsexy, opaque slices of the boring B2B economy. You are hunting for industries that are heavily reliant on unstructured data, industries that are deeply regulated, and industries that have been entirely ignored by Silicon Valley because the total addressable market isn't big enough for venture capital.
The sources outline the perfect targets. We are talking about commercial real estate underwriting. We are talking about maritime logistics compliance forms, specialized medical billing codes for obscure procedure.
Boring stuff.
Exactly. The exact compliance documentation required for independent freight brokers operating out of the state of Illinois. These are the gold mines.
Because these are industries that currently run on brute force human labor. They employ armies of highly paid operations staff whose entire job consists of opening PDFs, reading unstructured data, and manually typing that data into legacy Excel spreadsheets or ancient ERP systems.
It is soul-crushing, error-prone work.
And it costs these companies absolute fortunes in payroll. That is exactly where you strike.
Let's lay out the precise 4-step playbook to capture this wealth. This is what you can execute this week. Step 1. Find the domain expert. You do not need to go to the library and learn maritime law yourself.
No, please don't.
You find an industry veteran who has spent 20 years in that boring niche. You partner with them. They bring the deep domain knowledge and, critically, the distribution network, the Rolodex of buyers. You bring the vibe coding leverage.
Step 2. Identify the bleeding neck. You are not looking to build a tool that offers a mild convenience. You need to identify the exact, repetitive, 3-hour manual data entry task that highly paid employees loathe doing every single day.
You want the task that causes the most operational friction.
Exactly.
Step 3 is the most counterintuitive part of the strategy, I think. Build the wedge. When you find that bleeding neck, do not try to build a massive, all-encompassing software suite to replace their entire enterprise legacy system.
Oh, that's a trap. Enterprise sales cycles take 18 months, and IT departments will just block you.
Right. Instead, you use your Agentic IDE to build a micro tool, a wedge, a lightweight application that sits elegantly on top of their existing systems. It doesn't replace their database, it just intercepts the unstructured PDFs, uses AI to extract the data flawlessly, and hands them a clean CSV file to upload.
It solves one specific pain point, but it saves them 10 hours of labor a week.
And because the wedge is so lightweight, the IT department doesn't view it as a threat. You sneak in the back door. Which brings us to step 4. Charge for the outcome, not the software. Do not charge $20 a month per user seat.
Right, that's old SaaS thinking.
If your custom tool is saving a logistics firm 40 hours a month in data entry, and that labor costs them $4,000, you price your tool at $500 a month per company.
The margins on this model are what make it so compelling. Because you built this tool in a weekend using natural language, and your infrastructure costs are negligible, that $500 is almost entirely pure margin.
And if your domain expert partner simply sells this micro tool to 20 companies in their network,
you're sitting on $10,000 a month in high margin, highly defensible B2B profit.
You have engineered a cash flowing asset out of thin air. But let's take a step back and look at the macro picture. If you execute this playbook, and you successfully scale this micro SaaS to $10,000 or $15,000 in monthly recurring revenue, what is the end game? You don't have a massive sales team. You don't have venture backers demanding an IPO. What is your wealth exit strategy?
This is the 5-year outlook for the vibe coding ecosystem. The exit strategy is what we are calling the micro PE flip.
The micro PE flip.
Yeah. The private equity landscape has rapidly evolved to absorb this new asset class. We are seeing a massive ecosystem of micro-private equity firms, specialized holding companies, and sophisticated marketplace platforms like Acquire.com and Flippa.
And these buyers aren't looking for the next Facebook. They are actively hunting for exactly what you just built. Highly profitable, bootstrapped, AI-native SaaS businesses with low churn and zero employee overhead.
Let's run the exact math on a potential flip.
Okay, let's do it.
If your niche logistics tool is generating $15,000 a month in MRR, that translates to $180,000 in annual recurring revenue, or ARR.
And because these businesses operate in sticky B2B niches with near 100% profit margins, these micro PE buyers are routinely acquiring them for a 4 to 6 times multiple on that ARR.
Which means that tiny software wedge you built to read PDFs can be sold for roughly $900,000 in liquid cash.
Look at the timeline of that leverage. You architected the MVP over a few weekends by strictly managing the context window of an AI agent. You operated it for 12 months, serving a tiny handful of corporate clients with absolutely zero employees on the payroll. And you exit 12 months later with nearly $1 million in cash.
The long-term trajectory here is that the definition of a founder just changes. You transition from building one monolithic company over a decade to becoming a serial micro-PE builder.
A one-person digital factory.
Exactly. You spin up a niche asset, scale it to $10,000 a month, sell it to a holding company, and immediately move to the next adjacent boring niche.
We promised you the exact playbook for the vibe coding gold rush, and that is it. It is actionable, it is highly lucrative, and it is happening right now. But as we transition into the second half of this deep dive, we have to pull back the curtain.
We really do.
We have to look at the terrifying flip side of this massive wealth generation, because the leverage is real, but the structural integrity of what is being built is highly unstable.
We need to talk about the dark side. I mean, if you are rapidly deploying complex software architecture to the live web entirely through natural language without actually possessing the ability to read or write the underlying syntax, what happens when the system breaks?
Let's ground this in the human story, because the psychological toll on these founders is becoming a very real issue. Imagine the claustrophobic, waking nightmare of being a solo operator in this space.
It's terrifying.
You own a B2B software company generating $1 million in annual revenue. You have Fortune 500 clients relying on your system. But late at night, you slowly realize your entire digital empire is built on a foundation of sand. You are trapped inside a massive, sprawling system that you fundamentally cannot read, you cannot understand, and you cannot manually repair.
This is the phenomenon we call the technical debt singularity. And to truly understand the mechanics of why this happens, you have to understand what is lost when you remove the human from the syntax layer. You lose the mental model.
Let's dig into that. When a traditional human senior engineer builds a code base over 2 years, they hold a vast, multi-dimensional map of that entire system in their head.
Right.
They know exactly why a specific database writing function was written the way it was. They remember the historical context of a weird bug they patched 6 months ago. They intuitively understand how a change in the front-end user interface will ripple down and impact the back-end database load. They have a holistic mental model of the architecture.
But an AI agent, no matter how advanced, does not possess a mental model. It does not understand your architecture in any human sense.
It's just predicting words.
At its core, the agent is a highly sophisticated statistical engine. It is analyzing the text in its context window and mathematically predicting the next most probable token or piece of code to satisfy your immediate prompt.
So on day one, when the code base is small, the AI can hold the whole thing in its context window and the code is pristine. But what happens on day 100?
That's when it gets ugly.
As you keep vibe coding, as you constantly prompt the agent to add new features, patch edge case bugs, integrate new APIs, change the UI, the code base swells. It exceeds the context window. The agent can no longer see the entire system at once.
And that is when the code base rapidly degrades into what developers call spaghetti code. Because the AI lacks a holistic mental model, it starts solving immediate problems with incredibly brittle, short-sighted solutions.
Duct tape solutions.
Yes. It will inevitably start writing redundant functions. Instead of modifying an existing piece of logic to handle a new edge case, it will just write an entirely new, slightly different function right next to it, loading the file.
The sources specifically highlight the nightmare of circular dependencies. This is where the AI hallucinates an architectural loop. It rewrites file A so that it requires data from file B to load. But earlier, it had written file B so that it requires data from file A to load.
The result is a total systemic lockup. And because the agent is just predicting the next token to make the current prompt succeed, it will aggressively patch these bugs with illogical, fragile workarounds that just pile up in the dark corners of your servers.
And here's the trap. Because you, the founder, cannot read the syntax, you cannot open the files and refactor the code, you cannot clean up the architecture, the technical debt compounds in complete darkness. You are just blindly prompting the machine to make it work, and the machine is blindly duct taping the system together to satisfy you.
The singularity event occurs when the technical debt reaches critical mass. The application slows down, Database queries start taking agonizing seconds to resolve, and memory usage spikes. And then, one afternoon, you ask the agent to implement one simple, seemingly harmless new feature, maybe just adding a new column to a dashboard. The agent writes the code, pushes it live, and that single addition severs a hidden dependency chain. The entire system collapses under its own weight. Total, unrecoverable system failure.
It is genuinely terrifying. I look at this dynamic and I think, you are flying a commercial jet plane that you built in your garage entirely by shouting commands at a robotic arm while reading a manual that you haven't actually bothered to learn.
You've paying passengers in the back.
Exactly. The systemic risk is immense, but the technical debt singularity is only the operational risk. We have to address the legal and financial nightmare. We have to talk about the security backdoor.
Right, because if you execute the B2B playbook we just laid out, you aren't building trivial consumer toys. You are handling encrypted payment data via Stripe, you are storing user passwords, you are managing highly sensitive proprietary corporate documents for logistics firms and medical billers. You are a high-value target.
When you vibe code a system like that, you are blindly trusting the AI agent to write flawless, impenetrable security authentication protocols. You are trusting it to manage user access permissions perfectly across a complex database schema. But you have to remember the origin of these models.
Right, they're trained on the open internet.
And the open internet, specifically open source code repositories and forums, is absolutely saturated with terrible, lazy, highly insecure code. The training data is fundamentally flawed.
Which means the AI can and will seamlessly hallucinate a subtle, catastrophic security vulnerability directly into your live application.
Let's give a concrete example of how this actually happens mechanically. Let's say you ask the AI to build a simple search bar so a user can look up a client's name in the database.
An experienced human engineer knows they must heavily sanitize whatever the user types into that search bar before sending it to the database.
Otherwise, you're open to attacks.
Right. If they don't sanitize it, a malicious actor can type a specific database command, like a classic SQL injection, into the search bar, and the database will execute it, potentially wiping all the data or exposing every password.
But the AI agent, rushing to satisfy your prompt for a working search bar, might grab a snippet of logic that fails to sanitize the input, or it might accidentally hard-code your secret master API keys directly into the client-side JavaScript, exposing them to literally anyone who hits view source on their browser.
And this is the crux of the danger. Because the founder cannot read the syntax, they cannot audit the security posture, they cannot recognize a SQL injection vulnerability.
So they just deploy it.
They seamlessly deploy these fatal flaws straight to the live production server, exposing the sensitive corporate data of thousands of users.
This brings us to the harsh, immovable reality of this new economy. When the inevitable data breach occurs, when a hacker exploits that hallucinated SQL injection and steals the credit card data of your B2B clients, who is holding the bag? You cannot subpoena an AI model. You cannot sue an algorithm for negligence.
No, you can't. The legal and financial liability falls entirely, 100%, on you, the founder. You are the CEO.
Exactly.
If you are standing in a federal courtroom or facing a massive class action lawsuit after a catastrophic data breach, the defense of, I didn't actually know how the code worked, the AI wrote it, and I just deployed it, is not going to hold up. In fact, it is an admission of gross negligence.
Vibe coding grants you the godlike power of rapid creation, but it emphatically does not grant you the omniscience of deep comprehension. It is the ultimate illusion of competence. You feel like a genius software architect right up until the exact moment you are held legally and financially liable for a complex system that you fundamentally do not understand.
It is a massive, unprecedented transfer of economic leverage to the individual. But it is an equally massive, often unrecognized transfer of existential risk. If you're going to wield this leverage, you have to build defensive guardrails, rigorous testing protocols, and eventually you'll have to hire human experts to audit the machines you build.
So let's pull all of these threads together and distill the absolute vital takeaways from this deep dive into the MediaGenX source material.
First, the 50-year technological arc has reached its zenith. Vibe coding has decisively ended the era of syntax. English is the final programming language, and Agentic IDEs have birthed the highly lucrative, profoundly disruptive 48-hour microsauce.
Second, the popular narrative around prompt engineering is a trap for amateurs. The wealth in this new economy will aggressively flow to elite context engineers, operators who treat AI not as a magical chatbot, but as a highly literal system that requires rigorous, heavily structured informational environments, deep database schemas, and flawless orgo integration.
Third, your executable playbook is to ignore the consumer market entirely and target the boring, technologically stagnant, high-margin B2B niches. Find the bleeding neck, build the micro wedge, charge for the massive labor outcome, and ultimately execute the micro PE flip for life-changing liquidity.
And finally, the massive structural risk that shadows all of this leverage. You are constantly balancing on a knife edge of compounding technical debt and catastrophic security liabilities. Owning a massive black box code base that you cannot read while serving enterprise clients is a ticking time bomb of legal liability.
Yeah, we want to hear from you. The leverage is sitting right in front of you on your laptop. We have a polarizing question for you to consider. If you could build any software application in the world this coming weekend, just by rigorously describing it in plain English to an agent, what exact problem would you solve? And who specifically would you sell it to? What is the unsexy, boring niche you would target to build your digital empire?
Let us know what niche you're eyeing down in the comments. It is endlessly fascinating to see how operators apply this raw leverage once they truly internalize that the technical barrier is permanently gone.
If this briefing provided you with a clear, actionable blueprint for navigating the vibe coding economy, hit the like button, make sure you are subscribed to MediaGenX, and share this deep dive with aspiring founders, side hustlers, and any frustrated developers who need to stop wrestling with legacy syntax and start architecting scalable empires.
And you absolutely need to be subscribed for next week's deep dive. We are shifting our focus from the digital code base directly into the physical wallet. We're exploring the algorithmic bank.
That briefing is going to be incredibly dense. We are covering AI-driven real-time underwriting, the total structural death of the traditional FICO credit score, the impending collapse of the 30-year mortgage market, and the rise of the trillion-dollar DeFi-CeFi hybrid matrix.
It is a complete and total restructuring of the global retail banking sector, and the capital implications are massive. You will not want to miss it.
Until then, stay curious, stay positioned.
And remember, everything discussed in this deep dive is strictly educational commentary. It is not financial, legal, or investment advice. Do your own research, protect your capital, and for the love of God, guard your code base.